Hey guys, this is Demoy Roberts from the AC, working on some general chemistry review problems in the preparation for some organic chemistry. And Dr. Betts will be making a video on this same exact problem, so if there's any confusions you guys have, he'll be making another video also in the ASC, and these problems will be available to you guys to do yourselves. Now, determine the formal charge of any atom in the following Lewis structure that require them. Now, we can see that this oxygen right here has two lone pairs, and this is oxygen's neutral state. Also, this whole compound right here, it's in a neutral state. There's no extra lone pairs. It's not missing any electrons or anything like that. This is neutral. So what we want to focus on is this atom right here. Now, what you guys want to think about is oxygen. Its neutral state is right here, like I said before. Now, we can see that this has a double bond, right? And we can see this oxygen right here has a single bond. So what we know is that this oxygen must have an octet, right? Or else it'll be very reactive. So we know that this oxygen would have three lone pairs. So 1, 2, and then I shouldn't have drawn the arrow there, but there's another lone pair there. So that oxygen has three lone pairs. So the way you guys could think about it is, from this to this neutral one has two lone pairs. This has a third one. So you could think of it as you've added more electrons to it, making it negative. So this right here is negative. And once you guys practice, you'll see that when oxygen only has one bond and it's to nothing else, it's always negative. For the other way, one bond is negative, two bonds it's neutral, and oxygen with three bonds is positive. So let's try the next one. We can see this here, that this is neutral. Neutral. And these are just lone pairs I'm drawing. You guys don't have to draw, it just helps me. But unless Dr. Betts asks you to put the lone pairs, if he asks you to put the lone pairs, then put them. So make sure you guys read the questions. Now, this oxygen is also neutral. How do I know it's neutral? It has two bonds. It's bonded to this carbon right here, and it's bonded to an hydrogen, excuse me. So this would have a lone pair like that. Or it would just look something like this. And Lewis dot structure, that's how it would look like from here to here. Right. Now, we could see here that nitrogen has a bond right here, and it's bonded to three hydrogens. Now, we know nitrogen has 5 valence electrons. The normal atom has 5 valence electrons. Valence electrons, right? So we can see this nitrogen right here has 4 bonds. So it's bonded like this. 1, 2, 3, 4. Now I'm gonna write you guys a neutral nitrogen. Right? So it would have 3 bonds, 2, 3, and an extra lone pair right here. So the difference between this and this is that this has a bond and this has a lone pair. So you can think about it like this. Since this lost its lone pair, that would make it positive because it lost its electrons. So that's why this one here would be, this nitrogen right here, would have a positive charge on it. And once you guys practice and get better, you'll see that every time nitrogen has 4 bonds, it's always positive. If you could think of ammonium and H4 plus. It has 4 bonds, so therefore it's positive. And that's all there is to it. So Once again, these problems are done in the ASC. Dr. Betts will be doing another video in case you guys didn't understand or I wasn't clear on anything, or if you guys want to see the formula, Dr. Betts will be doing another video in the ASC. So I wish you guys good chemistry.